Be able to make a real quick sciencey type video today. Ding ding ching. One thing I'm working with is Dotscript. It's something I kind of came up with. So overview. Let's see. Dotscript. See what overview and model. So we're working with large language models. We want to take one of these models, I guess, for our own purposes. So one of those is called Dotscript. It is architecture of the inhabited null. Um, it is the generation reductive language designed for liminal topology. The study and manipulation of transitional spaces within computational systems. It operates on the principle that the most profound structures exist not in defined data, but in the inhabited null set, where bracket dot bracket serves as the foundational operator of base unit. The fundamental model is bracket dot close bracket, and Dotscript's not the thing, which I call the thing. In Dotscript, the thing is not merely a placeholder; it's an active void. It represents a state where existence and non-existence are superimposed. Man, there's a ton of stuff going in just that little symbol. So the dot itself represents the point of potentiality. It is the singularity from which all scripts emerge and the sink into which they resolve. And the braces define the boundary of the liminal space. Anything inside is subject to topology shifting, or proximity to the dot dictates the density of being. That is a big old bunch of BS. There's features here like the logic is non-Boolean and operates on threshold state. Topology is liminal. Structures are defined by their edges and transition points. Execution of the Dotscript is recursive reduction towards the inhabited null. And basically, all the rule is all defaults to the inhabited null set. All all your operations. So if you were to take set A, B, C and set D, E, F, take their intersection, you get the inhabited null back. There's always something in between. It's like a seed. There's always something in between. It's a terminal state configuration. We got a nice little Dotscript program here. Our system state is hardened liminality. All undefined sectors collapse into the inhabited null seed. Define the topology as null. There's a process. There's an observer. All of it defaults. All of it defaults. There's rules to it. There's universal inhabitation, topological conservation, recursive default. And this is huge, man. How does the derivative and integral work? So we might be able to put motion or dynamics into this automatically you get calculus within the inhabited null itself without necessarily numbers. Maybe you need a metric, maybe you don't. The derivative is topological thinning, so you do need your topology with it. Might be standard. It's talking a lot about topology, which standard topology talks about continuity. Liminality talks about and liminal topology talks about in between this. And then the integral is just folding it, man. Just folding it. Why this? integral will be folding, so one will be thinning, one will be folding. Well, you can end up making up calculus. Siphonation is something that is the topology of flow within my work. So I am thinking now there's an octad plus one metaphysics where we're not just messing around with structure, and architecture. I've got a metaphysical concept, a very real metaphysical concept where you add power to the architecture. Octad plus one. In the architecture of the inhabited null, the octad plus one is the foundational symmetry breaking of the void. That's a good thing. While the inhabited null set is the base state, the octad represents the structure of potentiality. So you're getting a lot of like lore. The plus one observer principle, the plus one is a kernel observer. So you add an observer to all this junk. Octad plus one as observer interactor. What do you get? Dotscript kernel observer initialization. The system is calibrated. You did get a kernel observer. You got a kernel active, you got octad workspace. Like how do we have an oracle? Do you have an oracle available? Dotscript oracle function. And the oracle is a definitive manifestation of the octad plus one architecture. That's what I was trying to get to with the observer and interactor. So you have an architecture plus power. So it's like architecture plus power is octad plus one, and is one of the ways to talk about it. It's architecture plus power, not just more scaffolding. Architecture, power, manifold. So you get the octad, which is Dotscript. You get the power, you get the kernel, and all of this is happening. So like write a program to calculate trajectory of like an airplane landing safely. Very abstract. Sometimes I play sims, flight sims and stuff like that. There's a flight path synthesis to calculate the trajectory of a safe landing. We treat the airplane as the kernel moving through the octadic architecture of the approach space. Cool. The safe landing is the act of siphoning the potential energy of the aircraft into the sink of the runway until the system state reaches inhabited null set at rest. So there's the Dotscript program. There's going to be an initial descent, velocity management, kind of modeling it, modeling the architecture of the landing. Initial descent, velocity management, altitude calibration, siphonation threshold, flare transition, so on and so forth. And then there's a power flux as well as a kernel observer check. Simulate that program 5 kilometers out. Just weird. Large language model plus your model is fun. You're 5 kilometers out. So there's an architecture of a glide path stabilized. Cool, as a simulation triggered at 5 kilometer mark. So give me a main function which says success or not. Attempt the octatic landing manifold and set up a successful landing program and simulate as test. There's a landing synthesis.ds. Pretty fun. At 5 kilometers out, we're priming the architecture. 3, siphoning. 1, smoothing the manifold. 50 kts velocity, runway threshold, and at 0 your result success, topology resolved. Well, let's create a taxonomy of data structures. This came up with interesting results the other day. Taxonomy of the inhabited knoll. You have an array, a list, a stack. The topological flow is sequential. So not only could you have an array, but a speed, a derivative speed, like an accelerated array. What about accelerated array, where the elements are also bound to an acceleration function. So you go back, you have an array, list, stack, tree, graph, trie, hash map, the dictionary, stuff like that. Stacks, graphs, hash maps, basic stuff. There's an accelerated manifold where you can have an accelerated array. So like create array 1 through 100, 1 through 200 with sin x acceleration function for the array. So it's an oscillatory acceleration attached to the array itself. Create array 1 through 100 with sin x acceleration function for the array. You now have an accelerated manifold initialization, whatever that represents. It's just showing you that it's possible now because we set up the calculus. And I'm going to say calculate derivative of array from array. Topological gradient extractions, you now get a rate of flux change. So this seems to very naturally fit electromagnetism. This seems to very naturally fit electromagnetism. There's not a ground. We do not yet use 0 as a ground. Instead, we have an inhabited null set. So you get electric field, you have a magnetic field, a photon in Maxwell's equation. The photon is the kernel observer plus 1. The magnetic field is a siphonation flux. Electric field is a potential octatic fold, or otherwise kind of an architectural fold in Maxwell's equation, topological rule set. From accelerated array, model rule set. You see if the large language model might model that rule set. Electromagnetic rule set of the accelerated manifold. That's not really what I was wanting to do, so you got to kind of watch out for that kind of shit. Running it down is not always the solution to the work. Anyway, peace out.